Okay. So, sorry about this. I so what we're gonna do is if you have log base 4 is 64, everything here can be done without a calculator. I do a base 4 over here. I do a base 4 over here. That's going to be 64 equals 4 to the x power. From there, you just figure out x to what power gives me 64. In this case, is x to the third power. Wait, but isn't it kind of obvious? What if you just know it in your head? That's what I'm saying. You could do it without a. Yes, you could write it without any work. In this case, if there's a 1 on the inside, it automatically becomes 0. If it's literally the same thing on the inside as its base, then the answer is 1. If you have something like this, though, let's say log base 4, I don't know, 2 equals x. Or it won't say equal x. It'll just say this, I guess, second line. But then you set it equal to x. Bring the 4 to the other side by raising it by a power of 4. So 2 equals 4 to the x power. In this situation, you're like, oh, wait, what the? How am I supposed to get 4 into 2? Well,
just do log 2 divided by log 4. Yeah.
You could also do it by the half power because it's a square root, okay?
So why don't you just square root 4?
That is, x would equal a half, though, because I'm asking what it equals. I know. All right, this set of questions you can't actually do with your calculator. In this situation, I'm giving you 3 made-up logs. I put log base x to represent it's some mystery number. So log base 7 is 1.23, log base 5 is 0.86, log base 3 is 0.41.
Wait, what's the question here?
So the questions would be this ones. So the question would be, what is log x35? Well, you don't know what the base is, so I can't use the change of base formula. As someone mentioned, just use the calculator. So I'm forced to rewrite this in things that I know it equals to. Well, I know log 35 is the same thing as log x5 plus log x7 because I can expand the logs and multiply them.
Wait, so what's the question?
So the question is, what is log base x35?
And you just write the 5 and the 7?
Well, that's not giving me the answer. I want to know what it actually equals. So in this case, log base x5, I know that equals 0.86. Plus, this is the table that I'm giving you, or some information I'm giving you. This is given. So then, log base x7, I know that's 1.23. So I just add them. So this is going to be 2.09 in this example. So you're kind of combining your expanding rules. Well, that gives me the answer because I could use these facts over here to figure out what this one is because there's some combination.
Oh, so you're giving us what they equal. We have to find.
So you have to break it down, find each piece, and then add it together.
So log x35, so you could do what? Take 5 times 7 equals 35?
Yeah, it's 5 times 7, which I could expand into log base 5 plus log base 7.
Okay, so the other one would be log 3, log x3 over log 7 squared or something like that?
Almost. Log x3, when you divide, it's subtraction, so minus log 7 to the second power.
Oh, so division is subtraction, multiplication is addition?
Yeah, just like the exponent rules, remember? So because of that, this 2 right here, I'm going to move it to the front. So minus 2 log 7. I know what log base 3 is. Log 3 is 0.41 minus, I know what log 7 is. 2 times log 7, 1.23. And then let me do the math first and then I'll let you answer the question.
It's going to be on the test.
So 0.41 minus 2 times 1.23. Was it 23? 23. And that's going to be negative 2.05. Last one, log x25. I'll do it over here.
Wait, no, I have a question.
Oh, go ahead.
For the 3 over 49?
Yes.
So do you do 7 times 7? Like, do you do 7 2 times?
So you can do 7 2 times, which is 7 squared.
Yeah.
But because it's squared, I can move that to the front. So I put the 2 in front.
Oh, wait, so I can't really see what you just multiply the.
So I do 2 times what log 7 is, which is,
So you do 2 times 1.23.
yes.
Well, why don't you spare it then?
You don't, no. Log rules dictate if you have an exponent on the inside, you move it to the front.
Yeah, no.
So, like, for example, this one, I'm going to rewrite.
Actually, my 2 is different than squaring it. And that's what you had. That's what you went from. You went from multiplying it by 2 to squaring. I mean, you went from squaring it to multiplying it by 2.
Okay, I would like to square it, but the issue is I don't know what log 49 is. So I have to manipulate it. For example, this one is log 25. I don't know what log 25 is, but I do know what log 5 is.
Yeah. So why don't you do 0.86 times 0.86?
No, that's not what it is. This is not log x5 to the second power. I'm sorry, I guess I understand what the confusion is. It is not this. It's not this. Whereas all of this to the second power.
Wait, so I know
It's
how to do-
within the log itself.
So I know how to do this. I know how to do this.
So what is going to rewrite it as?
So then 2 log 5.
Good.
So then it's 0.8. 2 times 0.86.
Good.
So it's 1.72.
Excellent.
So you do need your calculator for this.
You don't need to do that for you.
You need it for
I do.
You need it for the other stuff. You just
The other stuff, the calculator helps for sure.
So how many questions is going to be on this test?
That's
so this
true.
is one section of the test.
That was one section of the test I just said. This was another section of the test.
What is that? What was that section?
The section we did in the beginning. How many questions there are? If graphing is one question, 19.
It's a graph.
2 graphs. All right. This one. No. This one. The structures will say expand a log. This says condense a log. You just match whatever here. If it's ln, you do ln. If it's log, you do log. If it's log base 3, you do log base 3. So it always matches.
Log if there's nothing, it's 10, right?
It's a visible 10, yes. So in this case, we're going to expand. So in this situation, I'm trying to expand ln x to the 4th square root of y a3. So I'm going to rewrite this as ln x to the 4th plus, because they're being multiplied, ln square root of y minus, because this is division, ln a to the 3rd. Yes.
Is expanding having the exponent or the number in front?
The number will be in front. You never move the exponent out. Or if it was to a power, you could, but
That's
not.
what I'm talking about.
Yeah.
So wait, so when you expand, you have exponents, and then when you condense, you have the number in front.
I mean,
Like, you know what I mean? Like, which one do you put? Like in the second one, the half is in front. Like, do you want it to be 4 ln x or ln
Oh.
4?
when you expand, you want everything, you want the smallest thing possible inside your log or your ln. So in this case, I'm going to try all my work to make sure x, y, and z, a is by itself. So I'm moving the 4 in front. I'm going to rewrite this as a half power and move that to the front.
Yes, you want everything in front of you.
Yes.
Okay, so no exponent.
No.
minus 3 ln.
X plus 1/2 ln y. You could put an ln y all over 2. That's fine also. Minus 3 ln a. So each, what I say, suitcase only has one thing each, okay?
The answer?
Suitcase?
Yeah. Because this one you're condensing in one suitcase. That's the answer for this one. For this one, condensing.
Oh, it's the first day of spring.
So we're going to take that power. We have a half power. Put it into your suitcase.
Square root of 16.
So it's going to be log to the 16 to the half power. What's the square root of 16? We actually know that.
4.
So log 4 minus log 100. Wait, when we subtract, what can we do? When we put them together? Divided. So 4 over 100. Notice it's one log. I find many.
You make it 25.
So you're going to make it log
25?
1 over 25. For this one, yes.
Is this gonna be like one of the ones that are gonna be like something like this? That's just hard to do.
I'm literally looking at the test and making a question based off the questions I see on the test.
This easy.
It's this level, yes.
How did you get log 16 half?
It's a half. It started off like that, so I put the
Yeah.
half on top, and then that's the same thing as the square root. So the square root of 16 is 4. All right, next one. All right. some exponent equations. So in this case, in this one, they're both base e, which means I can ln both sides and eventually cross them out, which means it's 2x equals x plus 2. Algebra 1 problem, x equals 2.
How'd you do algebra 1?
A couple. I just cross out the e's and then it's 2x equals x plus 1, which you could do from algebra 1.
Wouldn't it just be log base?
How'd you do that?
Oh, are we?
Oh,
or
x.
it's log base 3, log base 4. I mean,
Say that one more time.
log base 4 on both sides.
And this one? Let me do this one next, and I'll save that one.
So log base 6.
So in this case, I'm going to have to do log base 6 on both sides.
Then it's 2x equals. Why didn't you do a common log base 40?
And this one I can't because there's no way I can make 40 into some power of 6.
Why do you just? Oh.
This one I will do that, but this one no. So then it's log base 6, 40, and then I divide both sides by 2. So x equals log base 6, 40, all divided by 2.
So why couldn't you do like 2 and 3? Can we leave it like that, or you need to and like?
No, as I said, you could do this via a calculator, so this would be left like that.
Can you say salt like?
It'll say in the instructions, put in terms of ln, logs, and e's.
Oh, and how do we know if it's calculated?
What are you talking about?
What if you want us to solve it?
No, we'll not ever.
No. There's some things on test that you want us to solve.
I don't know how to answer that. It's just
Oh, well, yes, we do need a calculator for that.
no, you don't. You don't need to type this in the calculator.
If you say like give the real number.
No, I don't want the real number.
Never? No, but for some things you're saying that you never know what.
There's nothing there that you need a calculator for, like logging something.
Actually, one question.
Yes.
So if it's e crossed out by ln, will there be one where it's like ln you have to cross it out by e?
Yeah, that'll be the log equation. So
And if it's like 6 2x, it's log, right? You cancel it out by log. Like if it's like that one, it's only log you can cross it out by.
what do you mean?
You see how like you did log 6 and you
Yes.
crossed it out? You can only put log next to it.
I only could log base of the whatever the base of the exponent is. Yeah.
Yeah, why isn't it ln of 6?
ln, that doesn't make sense. ln is particularly for e.
Do you ever have a 6e?
6 times e.
Like ln 6e?
You could, but then would that wouldn't be just 6. That'd be ln 6 plus ln e. So then you'd be ln 6 plus 1.
Wait, e is 1?
No, ln e is 1. If you do ln and then e to it, it's 1.
Oh, is log 10 1?
Log 10 is also 1, yes. All right, so this one, 3x, 8x plus 1. In this case, we have 2 exponents here, so we see if we can match the bases.
2 squared and 2 cubed.
So I'm going to rewrite 4 as 2 squared, 3x. And I'm going to write 8 as 2 cubed, x plus 1. So then it's 2, 6x equals 2, 3x plus 3. Wait, they're the same base. That means I could cross them out, aka log base 2 of them.
Do you always want to get it to be the same base?
Yes.
Sometimes you can't do it.
Like this one, you could not do the same base, but this one you can. So then it's 6x equals 3x plus 3. A little bit of simple algebra. X equals 1. Yeah.
How is it 6x though?
What?
Oh, wait, I missed this stuff.
And he got mad at me because look at me.
All right, Ellie, you got it?
I got it.
All right. Then there's log equations. Log base 3 x equals 4. So in this case, I need to get rid of the log from the x. So I'm going to raise both things by 3, or I don't know, undercut it by 3. So that's going to be x equals 3 to the 4th power, which would be 81.
Why did you do that when you just rearranging the head?
You could just rearrange it. I'm explaining why it
Yeah,
is.
why isn't it just 3 to the 4th equals x? Why do you have to do the 3 on the bottom thing?
I'm just explaining why it works, but
Can you
you.
really explain that? I'm confused. Why did it become x equals 3 to 4?
So if I have to do the same thing to both sides. So what I did is I put the base 3 of an exponent, or in other words, you could say I made this an exponent, I made this an exponent. And when I do this 3 log base 3x, when I have the base of an exponent and the base of the log matching, it crosses out.
Can I show a trick for this?
So how does it become 3
Come
to
here.
the 4 power? That was 4.
Or should I write it on your
Oh, because that's
computer
your
so you're
base.
watching
3 is
the
the
video?
base of it.
If you draw on the board, it'll work. So what's up?
Oh, wait, on that
3
one?
would
Yes.
become the base.
Yes.
What do
3
I
will
draw?
become the base. Yes.
What do I draw with?
Your finger.
Oh, really?
Yes.
Okay, so look. If you have. That's really cool. If you have this. Okay, so this is the same problem. So you take this number and you carry it around into a circle and you take that one, that becomes the exponent, it comes up here, and then you just put the x on the other side.
You don't need to do all that. You
It's
just-
so much easier.
The base, you put the 4 above the 3.
Yeah, that's
That's-
what I'm saying. You take it
No,
and you
that's-
carry
Well-
it
It's
over.
in your head.
But why don't you just write it like this then? So it just goes underneath. Why would you do a circle?
It's whatever works.
I just came
Yeah.
up with it.
All right,
And
we'll put it in the.
I think I'm the best at it in the class, so I just wanted to help out.
That's very humble.
I just wanted to show.
Next one.
When's the test? Tomorrow.
Log base 2 x squared equals 6. So in this case, I'm moving the base 2 to the other side. X squared equals 36. Or 2 to the 6. Oh, wait, it's 2 to the 6th power, my bad. Not 6 to the 2nd power. So 2 to the 6th power, which is 64. Then I want to solve for x, square root both sides.
X equals what? 8?
X equals plus or minus 8. Don't forget, when you square root in an
So
equation,
if I just put 8, I'll get half a point off.
yeah.
What's 2 to the 6th power?
2 to the 6th power is 64.
So why can't I just do cross the 2's and do 2 to the 6th power? Oh wait, that's
Yeah.
So I don't know if I can go and then go back to think I have to do one next day. I mean, I was getting mad right now. I'm so mad. And then
Okay, next one. Log x plus log x plus, not plus, x minus 3 equals log 40. All right, in this one, because it's a plus sign, I can't cancel out the logs like I did in the previous questions until I condense them. So I'm forced to condense them first. So it'll be x squared minus 3x inside that log equals log 40. At that point, I could raise both bases by 10, aka cross them out. Why am I allowed to do?
because this is imaginary 10 now.
Yeah. 3x equals 40. A little bit of rewrite. X squared minus 3x minus 40 equals 0. This is algebra 1, just in January. So then we factor x minus 8, x plus 3, x plus 5, I should say, equals 0. So negative 5 and 8. Remember, though, no negatives inside of the final result of a log. So 5 would cause that problem. If I plug in an 8, that's okay, and that's okay. So that's okay. So the only real answer is 8, okay?
Wait, why does it have to be a positive?
You can have a negative in a log because, let's say, log base 3, negative 2, let's say. Or let's do negative 3, that's an example. Now, the problem is, let's say you put it in x, move the 3 over here. Negative 3 equals 3 to the x power. There's no exponent that can change into negative. I can make it really small with a
So
fraction.
no matter if we have a negative, it's always supposed to be a positive.
What's up?
What if you have two positive?
That's normal. You mean two negatives?
No, two. Let's say two positive, so that you have two answers for that.
It could be both positive, but let's say in an alternate universe, let's say I got like
Two negatives.
no, let's say I got 1 and 4. In this case, the only answer that works is 1, or the only answer that works is 4, because Ellie, you gotta ask me. Come on, pay attention. If I plug in a 1 here, so that'd be okay here, but 1 minus 3 causes a -2, so this would not count.
Oh, so I would have to take what if I had two positives, I would have to put them in and see if it works.
Yeah, you just gotta check.
Okay.
Sometimes both answers work. It's hard for me to make up one that offhand, but
Yeah. Okay.
okay.
But most of the time, you won't have to that work.
Yeah. And then a real quick example here, log x plus log x plus 21 equals 2. Yeah. So almost the same thing. Just remember, in this case, x squared plus 21x log equals 2. In this case, when I raise both sides by 10, this one will not be canceled out on the right
It
side.
has become 21x and not log 20. Oh.
Wait a second.
My bad.
Why is it not log 20?
I don't understand. Why don't you multiply it?
What do you mean? The opposite is 10 to the second power or 100. So the math changes a little bit. So make sure if there's no log here, you can't just cancel out the log. There's no log to cancel out. So make sure you actually move it over like the proper log.
So how did you get from 2 logs to 1 log?
Because if there are plus in between, you could condense them.
Oh, you can just cross them out?
Afterwards, you cross them out, but you could condense them every time.
Oh, x plus 25, x minus.
Yep. And then just check, -25, 4. Only -25 causes a problem, so only 4 is your answer.
What if we both cause a problem?
Then you have no solution. I have to take time in the kitchen to cook that one up. So.
Yeah.
Except one person.
No. The last test?
What quiz? People got 100 on that quiz.
We were like
Yeah.
y equals 0 or whatever.
It was like the stupid y-intercept. It was like
Yeah. It was so much.
Because it's 4 equals 0. That's no solution. That's obvious.
It's so obvious. That took me half of a quarter.
See?
Oh man.
It was a given. I didn't.
All right, graphing. Graphing. Let's say 4. Let's put 2. No, let's put a half. 1/2 4 x minus 2 plus 1.
That's 1/2 times 4?
Yeah, half times 4. That's to point out the 4 is the only thing that's being affected by the exponent x minus 2. 4 does matter for one part of the question. All right. So on the question, I would say, how is the transformations compared to 4 to the x power? AKA, it's normal form. So in this case,
G equals 4.
what? No. So what we're going to do is identify our A, H, and K.
Wait, yes. If you have G to the x and 4 to the x, then G equals 4.
No. That's a function. That's not.
H is 4.
H is no.
That's x. -2.
Just 2 though, because it's H is always flipped. And K is just 1. So this is a vertical shrink by a half. This is a to the right 2. And this is going to be up 1. Okay. Now, in this question, I will ask if it's a growth or decay. Good. The number inside the exponent is greater than 1, so it's a growth. If it's less than 1, then it's a decay.
On your video, you wrote 0 less than x less than 1.
It can't be negative, so
That meant it was a fraction.
yeah, it's going to be a fraction. Or
But
something.
what if the fraction is greater than 1?
Then it's still growth. Then it's a flat line. Because 1 to the exponent, no matter what it is always 1, 1, 1, 1, 1. To be a flat line, want to be an exponential graph, so no.
So we're not doing the flat line one?
No. And then you graph it, but in this case, I highly recommend just taking your calculator, plug it in here.
Oh my god, Mr. Cole, I found a TI-84 in my mom's closet.
Your mom's closet.
Yeah, she had 2 TI-84s in there.
That's good for
I
her.
stole like 30 from the school. So.
But they're numbered.
Anytime you just see one lying around, I take it.
That's really smart, actually. You could sell it on eBay.
You're just trying to activate somebody.
Someone would buy it on eBay for like $80, I guarantee it.
It is a hustle.
That's where the Lisa Clemens tried getting to have it.
Good thing she wasn't listening.
It's on video.
All right. So you graph. Now you're like, okay, how am I supposed to graph that? You just go second table, and then you just graph some points. You know, 2, 1.5, 3, 3.
We don't have to do like the vertical asymptote stuff, right?
There's no asymptotes here, so no. Well, there's technically horizontal asymptote, but no.
Technically,
We
there
can
is
just go-
Yeah, you could just go like that.
Yeah.
Yeah, I just want to make sure you do it correctly. So
because
because it could look like this if it's a negative flip, it would look like a decay, and this would be a negative decay. So
and also
My
like
best friend, Chris,
since
was
it's on
absolutely gorgeous.
go ahead.
since like the default's automatically going up, right?
Yeah,
It's automatically +1. So if it was down like 3, it would be -2.
yeah.
See you with the Tesla.
And
See you around, bro. Peace.
it's a
So last one, a log graph.
Wait, but we didn't graph it.
It doesn't matter the graphing of it. It's just get the general shape for me, and I'm happy. Okay. And then, so if you lose a point on that, that's a shame. And then last one. That's not where I mix it. I mix it in the last set,
Oh, I'm right. Don't worry.
in the log equations.
and there's this TikTok that was
Plus 2. Very quickly, A is a vertical stretch by 2. H in this case is right 4 because it's positive 4. Your K is going to be up 2.
I sent him that.
You could type this in your calculator, but it will look like this.
Growth, right?
No, you don't describe it in this one. This is a log equation, so log equations don't have the growth or decays in that way.
Okay. That's easy.
It's easy as that.
But it automatically starts 1. It's like 1, 0.
Yeah. It starts at 0. No, 1, 0.
Then the exponential.
No,
graph
but don't
starts
you
at
not put a graph so all we have to do is put the shape?
I put a grid, but I'm not grading on the points, honestly.
Shape right, then we're good to go.
Yeah, I'm literally. It's a 1 point part of it.
And you